Hello, Tomáš is here bringing another programming drill. This video will just cover basic fundamentals about strings. In this video, I will just cover some basic stuff about string, just bring some informations about it, and in next video will be practical one. In this one I will be just showing some stuff which may be confusing. I'll just explain some things that I think is good to know, good to know, and where to give some carefulness. So let's start with it. Strings are just arrays of characters all the times. It's usually should be like character, and it's end by 0. We have also character data type, which looks like this, and this basically means the 0. It's just byte where is 0 inside. This is string literal. String literals are hard-coded into the source code, and string literals are also brought into a generated binary file from compiler. So in our program there will be this string hard-coded, and in this case we are creating here array which should exist in scope of main function. We are creating it just right here on this place, and this is the initialization of the buffer. These two are exactly the same thing. We have 3 characters and 1 string ending character. This is exactly the same. String ending will be there explicitly as well. So these are the same, but careful, this is something else. Here we are taking just pointer to string literal, and this string literal will be hard-coded in our binary file, which means that we can't change it. Basically, we can't change the string which is hard-coded in binary file, right? So in this case it's just a pointer to something and it's constant. Therefore this const here is important because the array exists somewhere in the memory, but it's different place. It's in the code actually. It's inside of code where are instructions. There will be some section where will be this array, this string, and therefore it's basically read-only part of the memory. Okay, let's see some features of it. So for each of these strings we will print out the value right here. We will print out string length, and we will print out the size of the thing. Yeah, these two are buffers. So let's see what it does. Yeah, I will comment out this just for now. Yeah, good. So as I said before, these two are the same exactly, and also the output is the same for them. String length computes just number of characters without the ending of the string. And here we have like string for this literal it will be the same for FIT, but the difference is size of here is size of this buffer, this array. which is 4, right? It's just 3 characters plus ending byte. In this case, where it's this one, it's pointer, so it's size of the pointer. On my system, pointer is 8 bytes, so I'm having 8 here. Okay, so this was easy, and now let's check this. I have here 3 functions. Each of them is taking the string as the argument. Each of them claims to do it in some different way. This one is taking the pointer. This one seems to be taking like the array of size 4, and this one seems to be taking like array of unspecified size. So let's use it on these functions. And let's see the results. As we can see, we don't even have any flags here, but we're still getting some warnings from the compiler. And warning is that we are using a size of on array function parameter, but it is const char pointer. So this was function 2, which is here, and as you can see, compiler doesn't care what I have here. Compiler just said nope, it's a pointer, and the same thing is here basically. And the reason is simple. Array lives here basically. This is the scope of the array, right? When you pass it to the function, we are not copying the whole array, right? I know in this case it would be worth it, like bringing just 4 characters instead of 8, but you know, array can be like megabyte. It can be megabyte, for instance, and copying here it will be costly. So so no matter what we write here, like these all are like possible to write here, but no matter what we write here, it will be compiler will consider it as a pointer and treat it as pointer, and also size of it will be the pointer. So let's see the output here. We're getting here all sizes are 8, and the same result would be for each of these strings. Okay, so this was nice. Let's comment this out. I hope this is now not too much surprising. And yeah, here is the example how we can compute the length, which we already did. Just note that string endings is excluded here. So string length is just 3, even though buffer is bigger. String compare function, we put here 2 strings, and it returns 0 when those strings matches. When they match, it's 0. It will be negative when buffer1 is lexicographically smaller, and positive when buffer1 is lexicographically bigger. So this is good for sorting, but careful that sometimes people use string compare interested on the match and forgot to compare with 0. It's like the common mistake I've seen sometimes, so careful about this. Okay, then in next example we want to copy the string into and make basically dynamically allocated copy of the string. There are 2 ways how we can do it. We can allocate by malloc string length +1 because we need also the string endings, and string copy then like this runs safely. string with if we haven't initialized enough space here, string copy will be disaster. Yeah, so careful about this. Firstly, resources to be allocated and ensure, and size have to be ensured it's enough. Then we can use string copy freely and without any problems. We can do the same thing by string up, which is just function which duplicates the string, and it does the same as is here. So it's the same story basically. Just one line. Okay, when we want to take a substring, we can use string ndup, and ndup means it's like a secured version of dup, or like limited by n basically. All these functions, we have also like string ncm. Do we have? Yeah, string ncmp, which will copy just to some size and like this. So these variants with n are like for security. So we pass here always as some argument the size we want to process, and it's not going further. So in this case, in this example, we want to, from this string, pick substring of this. And this is how we can do it. So we can use string ndup, and we can just improve the starting position. So here is first character, so 1, 2, 3, 4, 5. So 5 characters we want to skip. We can do it like this. Sample plus 5 would be a pointer to this L. 5 characters are skipped. Okay, language. It's 8 character long word. 8 characters. We can put here 8, and it will make for us the substring here, language. Note that here n means how many characters we want to bring into the into copied array, and so basically not with so basically resource is bigger. Yeah, resource is bigger. We doesn't know how it can allocate for 9 without any result, without any problem. Okay, so here we just print it. Of course, like dynamically allocated memory, we should always free. And there we have another example. When we have string, we don't know what it is, right? And we have allocated buffer. In this case, we can't use cpy, because basically we have to ensure the size. Buffer is always limited, right? Then here by 16 characters. So we can do it like this. This is the destination we want to copy in. This is our source, and this source is bigger than our destination, and as a limit here we also have to put here size of buffer -1, so 15. And it's the same reason, it's still counting just number of characters, not the termination symbol. When we have memcopy, it's different thing. It's a memory copy, and there we just limiting by size of the buffer. But when it's string copy, we always limiting just the size of the string, basically that the same thing what we have from string len. Yeah, so this is how. And then we have last example, and last example is about traversing of the string. And here we have four ways how we can do it. And first one is stupid. Don't do it like this. Why first one is stupid? The idea is good. I want to go from I will have just I as the index. I'm going from 0 and less than string length. It's a good idea. Execution of this idea is bad because of string length can't read the size of the string just from somewhere. String length doesn't know. So what string length does is that string length have to iterate to the end of the string, and during that counting how many characters it has, which means that for this loop, this is entering condition to the iteration, right? So for each iteration, this string length have to count the size of the string, and then it can compare and evaluate the condition. So for each evaluation of this condition, it works like this. So this will be, instead of on in time complexity, this will be on power 2, just because of this stupid thing here. How to fix it? Easily, we can just compute it in advance like this, and then just use the variable here. And now it's on. Yeah. We can also do it without any use of string len. We can use same trick as string len does, and it means that we can have I like this, and then we can just look at the character on the index. When it's not 0, when it's not termination character, we just proceed the loop. When it is 0, we just terminate the loop, right? So this works. It would also work like this without this comparison. Like C programmer would write it probably like this, because C programmer knows that 0 is always false in C. So this is basically, this works still, but this is more obvious what we are doing. So let's do it in obvious way and don't show up with tricks, right? It can be like sometimes confusing for us when we confuse ourselves. So rather, don't confuse yourself if you're not comfortable with this, and rather write it in a way you understand. Okay, the last one is the similar as the previous one. Basically here we just make the pointer which is initialized as the buffer one, which means it will be pointer on the first character, basically. Here is basically the same condition as what before in previous example, because p, the reference by p is the same thing as p on index 0, like this. Yeah, these are same, and here we just move the p to one character forward. In this loop we don't have I, we don't need I, so we can't print it. It is like another way how to do it. Of course, he would also work this. But as I said, don't confuse unnecessarily yourself. Yeah, if we would like to compute I here, I would rather pick this loop, to be honest, but we can still do it by int. We can use pointer arithmetics. So, and it will be pi p minus buffer. So we can subtract to address. This is address which is by I forward, right? Because here, if I want to compute p, it would be like this. P is here buffer plus I, and like this pointer arithmetics works. Yeah, so it's just different. It's just like some manipulation with equations, and we can got I here even if we are using pointers, but this is just for a curiosity. I hope I covered everything I wanted, and I hope this will be useful. And in next video we will be practicing strings. So next video we will have tasks. So see you in next video.